Continuing our discussion related to tangents, in this tutorial we are going to learn a little bit more about the properties of tangents, okay? So here is our scenario that will help us explain a lot of different points. In this one we have that if two tangents are drawn from an external point to a circle, then prove the following. Number 1, the tangents are equal in length, and number 2, the tangents from a fixed point subtend equal angles at the center of a circle, all right? So here is my circle, which is a diagram relevant to the above problem, and we have this fixed point B that is external from this circle, and let's say this is my center right here. All right, now we need to prove a couple of things. One, we need to prove that the tangents are equal in length. So if AB is my tangent, which is tangent 1, this is equal to the second tangent, which is the distance BC, right? So we need to prove these two dimensions are equal, and the second is the tangents from a fixed point subtend equal angles at the center of a circle. So if you were to draw a line connecting the point B to the center, it will be something like this, and the angle that will be subtended by this tangent AB will be, let's say this is angle 3, and then the angle subtended by tangent BC, let's say that angle is 4. We need to prove that angle 3 is equal to angle 4. Okay. So let's say this is my center O, and let's do a few more things. Let's connect the center with the point of this tangent A, and then connect the center with the point of this tangent at C. Okay. Now what exactly you have by this arrangement? You notice that I already have a 90-degree angle here, right? And then 90-degree angle here, because this is one property that a radius is always perpendicular to the tangent. We just proved in our previous tutorial, right? Now you have two different triangles. We have triangle OAB, and then you have a triangle OBC. Right? What do you see as similarity between these two triangles? We know that the line segment OB is identical in both of these triangles because it's a common arm between these two triangles, right? And then you can also say that the line segment OA should be equal to the line segment OC. Why? Because it is nothing but a radius of the circle, right? So what else you have? What else we have is this angle at vertex A is equal to angle at vertex C. This angle we are talking about, because they both are 90 degree, right? So you see, now we have very interesting finding. We have side, and angle between two triangles as equal, and that means these two triangles are congruent to each other, right? Straightforward. But what happens when you have two triangles that they are congruent? That simply means all of their corresponding sides are equal, and that will conclude that the side AB is equal to the side BC, which is what we wanted to prove here. And also it tells me if two triangles are congruent, all of their corresponding angles will also be equal. That means the angle 3 will be equal to angle 4 because both of them are corresponding angles, right? You can also deduce one more finding, that the angle AOB will be equal to angle BOC, right? Because they are also corresponding angles. So just with one simple relation that you found, you can have three different findings: that the tangents are of equal length, the angles subtended by the tangents are also equal. With that in mind, let's make use of this application to solve some practical problems. Okay, so let's go there. So our task is this: in two concentric circles, the chord of length 8 centimeter of the larger circle touches the circumference of the smaller circle. Okay, if the radius of larger circle is 5 centimeter, find the radius of the smaller circle. Okay, so let's say this is my larger circle. Let's say this is CL, and the one which is inside, let's say circle which is a smaller circle labeled as CS. Okay, and since these two circles are concentric, so this is my center of both of these circles. Okay, so let's draw a chord such that it touches the smaller circle. Okay, so here is my chord and it is touching the circumference of the smaller circle. Let's say this is my chord A, B, and this is the center at O. And this point where this chord is touching the circumference of the smaller circle, let's say that point is C, all right? So what we need to find is the radius of the smaller circle, which is nothing but this distance OC. So what is that dimension? Now, what you're given is the radius of the larger circle is 5 centimeter, right? And the length of this chord, and that is AB, is 8 centimeter. Now, let's draw some lines and complete this diagram. Let's connect the point O with A and then connect the point O with B. Okay. So this gives you one triangle OAB. At the same time, it also gives you two more triangles OAC and OCB, right? So by the way of this arrangement of triangles, you will see that we have a triangle OCA and then you have a triangle OCB. And they both are equal, they are congruent. We just proved that in our step 1 because the line segment AB, which is 8 centimeter long, is a tangent to the smaller circle, right? That means the distance AC is equal to distance CB because these two triangles are congruent, right? But if these two distances are equal, that means C is nothing but a midpoint of this line segment AB. That means each one of those has to be equal to 4 centimeter because AB, the total length of AB is 8 centimeter. And you can also tell that the line segment OB is 5 centimeter. Why? Because you see the distance from O to the point B is nothing but the radius of the larger circle and it's already given to us 5 centimeter. So by the way of this arrangement, you can say that OB square is equal to OC square plus CB square. So what is OB? It is 5 square. What is OC? That is what we need to find. And what is CB? CB is 4 centimeter and that's 4 square, right? That will be simply implying that OC square is equal to 5 square minus 4 square. OC is square root of 5 square minus 4 square, which will be 25 minus 16 under the square root, which will be square root of 9, and that will be plus 3. Because square root of 9 will give you two values, plus 3 and minus 3. But since the distance OC is a positive distance, because distance cannot be negative, hence we always take the positive value of this square root. So simple enough that we find the radius OC, which is the radius of the smaller circle, is equal to 3 centimeter. So the key point is this problem that was very difficult at its statement was rather very simple, and the simplicity is in understanding the properties of tangents to a circle. Okay. So once you have that, create the relevant diagram and then that's how you solve your practical problems in geometry, right? With that, we will take a pause here. This completes our module on the properties of tangents, okay?